Okay, in this lesson, we will be learning about how to simplify surds. Okay, let's begin by these two given examples. Let's start with this first example. Square root of 3, quantity, or multiply to the quantity of 4 square root of 2 plus square root of 3. Actually using the distributive property of multiplication over addition. That means we have to distribute or multiply square root of 3 to both addends 4 square root of 2 and square root of 3. So when we do that, we can actually apply the first law of surds wherein since this is 1 here, so if there's no number or numerical coefficient before the surd, that means it's understood to be 1. So we can multiply 1 times 4, that will give you 4. Square root of 3 times square root of 2 is actually equal to square root of 6. When you multiply square root of 3 to square root of 3, that will give you square root of 9. This is actually a special case for your first law of surds, wherein you're multiplying similar surds. So that will give you 4 square root of 6, and we can simplify square root of 9 because square root of 9 is equal to 3. Now, can you simplify this further? Not anymore. So your answer is 4 square root of 6 plus 3. Now, let's observe the second example. Okay, in the second example, you can always do distributive property here. So which means, observe that you have to multiply numerical coefficients to numerical coefficient and radical to radical, or surd versus surd. So 3 times 2 will give you 6, and that's the square root of 5 times 5 is equal to 25. Okay, 3 times 5 is equal to 15, and since there are no radicals here, that means you're not going to multiply 5 by square root of 5. Okay, because it's numerical coefficient versus numerical coefficient, surd versus surd. But this year we have no surd here, so therefore that will just be square root of 5. So just imagine 3x times 5. 3x times 5 is 15x. Okay, so 15x. So we just represent square root of 5 by x. So what we can do here, we can simplify this further. Square root of 25 is equal to 5. Plus, we can simplify this expression any further. So that means we can simplify this 6 times 5. It will give us 30 plus 15 square root of 5. So we can combine a constant and an expression with radical. So therefore, your final answer is 30 plus 15 square root of 5. But you can actually have an answer in factored form because both of them are factors of 15. So you can have 2 plus square root of 5. This is common monomial factoring. So we have quantity of 5 plus square root of 2 multiplied to the quantity of 6 minus 3 square root of 2. Just imagine you're multiplying x plus y times a plus b. So when you have this kind of form or factors, you have to do FOIL method. Okay, so let's apply FOIL method in this given example. So when you do FOIL method, you start with the first term, followed by the outer terms, then the inner terms, and then the last terms. Okay, so let's begin with the first term. 5 times 6, that's equal to 30. Now 5 times 3 square root of 2, that 5 times negative 3 square root of 2, that will give you negative 15 square root of 2. Remember, if there's no surd here, that means you just multiply the number to its numerical coefficient. Now, square root of 2 times 6, you cannot multiply 6 and 2 since this is a constant and this is a surd. So that means you're multiplying 6 to 1 numerical coefficient in square root of 2. So that will be positive 6 square root of 2. And then, of course, square root of 2 times negative 3 square root of 2. This time you have to multiply 1 and negative 3. That will give you negative 3. And square root of 2 times square root of 2 is equal to the square root of 4. Okay, now let's simplify this further. We can have 30. And since you already know that these two are similar radicals, why are they called similar radicals? Because they have the same surd. Then you can combine these two terms by negative 15 plus 6. So just remember, you just combining negative 15x plus 6x. So that will definitely give you 9x, or 9 square root of 2. While this one, you can have 3, and the square root of 4 is 2. So you have taken out 4 from the radical because 4 is a perfect square. So which means we can simplify this further as 30 minus 9 square root of 2 minus 6. And we can simplify this further because we have two constants here. Then we can combine the constants. Of course, we cannot combine the surd because it's not similar to the other constants. 30 minus 6, that will give you 24 minus 9 square root of 2. Since you cannot combine this any further, or you can simplify this any further, your final answer is 24 minus 9 square root of 2. The expression 4 square root of 5 minus 7 square root of 3 is under the power 2. Okay, and remember, x plus y, quantity squared, is not equal to x squared plus y squared. Okay, remember that one. So that means we cannot just distribute 2 to each of the items here, but rather x plus y, quantity squared, is equal to x plus y times itself, x plus y. Let's expand the expression first. That means we can have 4 square root of 5 minus 7 square root of 3 multiplied by 4 square root of 5 minus 7 square root of 3. Okay, just like what we have done in the first example, you use FOIL method. Okay, let's use FOIL method, and let's begin with the first to first term, outer to outer, inner to inner, and last to last. In this case, we can have 4 times 4 is equal to 16. Square root of 5 times square root of 5 is square root of 25. 4 times negative 7 is negative 28. Square root of 5 times square root of 3 is square root of 15. Negative 7 times negative 4 is negative 28. Square root of 3 times square root of 5 is square root of 15. Now, negative 7 times negative 7 is positive. It's positive 49. Well, square root of 3 times square root of 3 is square root of 9. So that is equal to, we can simplify each term first. Okay, so 16 and 25. 25 is a perfect square, so that means 16. And the square root of 25 is 5. Now, as you have noticed, we have similar terms, negative 28 and negative 28 square root of 15. So you can actually combine them. Just imagine it's negative 28x minus 28x. So that gives you 56x, or 56 square root of 15. Okay, and then plus 49, and the square root of 9 is equal to 3. 16 times 5, that will give you 80, minus 56 square root of 15, and 49 times 3 is equal to 27, 147. We can actually combine similar terms this time, which are the constants. So positive 80 plus 147 will give you 227. Minus, of course, we cannot simplify this 56 square root of 15 any further. So we just have to copy this. Okay, and since you cannot combine constant and the surd, so therefore your final answer is 227 minus 56 square root of 15. Okay, so that's how you expand and multiply surds. So just be careful in multiplying an expression with a constant and a surd versus a surd or just a constant. Okay, in the next video, you will be learning how to rationalize the denominators of your radical expressions. See you. Bye.